We are moving to the last section, data-driven production. I would like to welcome Steve Etkin from Intelligent Plant, telling us something about new software business models for the future. Steve.
Thanks very much. And I'd like to say thanks for the opportunity to talk here. Thanks to the organisers, really appreciate that. So I'm Steve Aiken, I live in Aberdeen. I care about the oil and gas industry because pretty much all the work in Aberdeen has a source in the oil and gas industry, so I'm a captive audience. A couple of slides repeat here to give you an idea of where we are in this presentation. So I'm going to start off reviewing the opportunities. What are the opportunities in the North Sea? And when it comes to software, they can be multiplied. You can take that and you can actually say, well, actually, we could do that everywhere. And that's really quite a big thing. Next thing is talking about a new software model, a different way of doing business for us, and something that certainly changed probably as a result of the change in oil price. So operators changed, and it actually made us change the way we thought about things too. And the last thing, I'm going to go through a system for experts and actually show you some real technologies that we're putting forward and the possible gains you can get with those technologies. So what's the size of the prize? What could you actually gain with software? The theoretical maximum, if you take production efficiency in the North Sea, it varies between 50 and 70%, so not quite as impressive as the asset in Norway, which sounded brilliant. And our current production is about 920,000 barrels of oil a day. So if you take that, then there's the opportunity to shift it from between 50 and 70 to almost 100. So if we take those numbers, work it out, then that's about 30%. This is, get the laser going. This is this year, so the future and this year are the same. But the future here, this is if you imagine if we just sorted everything straight away and saying, well, what would the opportunity be worth if we did that? And with that, it's actually an increase up until 2035 of 1.4 billion barrels of oil that would come out of the North Sea that wouldn't if we didn't do this. That's a massive number because it's $56.7 billion. And it's absolutely astounding. And it's a brilliant opportunity. And I'm really excited to be part of trying to make this happen because I honestly believe Aberdeen has a much bigger future than most other people think. So we started thinking about that problem and we spoke to a bunch of people. We actually spoke to Alex Kemp about the economics of oil and gas. We spoke to the Oil and Gas Authority, sat down with all of them and spoke about these things. And we read a report. It was really interesting. And these are the numbers that were in the report. It analysed compression losses. One of the big losses we have in the North Sea is around compression and compressors tripping, downtime events because of compression. And this was an analysis done where they did root cause. It took about a year and a bit to do this. And they came out, and what was really interesting for me is actually, normally people concentrate on maintenance and think things aren't maintained and that's why they trip. That's what people normally concentrate on. But when you look at the other side of that pie chart, that's what we really need to be concentrating on. We need to be concentrating on how we operate. So we're then looking to put forward software to try and help people change the way they operate. And previously we would do that the old way, which has lots of red arrows. I'm sure it wouldn't have at the time we were doing it, but now it's red. So initial costs, support costs, internal costs. I'm going to go through this in a second, but this is the summary. We'll see this again. So there's a new way that it's in the App Store, and there are two ways that in the past we used to do this and we saw problems with. So I'm going to go through how that happens. And there are two people when this happens. So you're thinking about building a piece of software that's going to advise people and change the way they do things. And there are two actors here. So one of them is the application developer, and he's over here. And the other one's the operator, and here's over here. So this is the application developer. Are there any application developers in the room? I know Siemens are, so that's one of them. Bruce is another, and any operators, right? So this is kind of relevant to all of us. And I'm going to be really interested if anyone's seen this happen before, because I have. So the application developer, he has an idea. He thinks, you know what? I know what the operator needs. I'm going to build a proof of concept. And I'm going to take that and I'm going to show it to the operator and I'll say, check this out. How cool is this, right? So he takes it and he says, you know what, I'll install this for you and I'll put this on your computers and don't worry about it, it'll be fine. And the operator looks at it and he goes, yeah, you don't really understand my problems. I have to speak to IT and they're not much fun. And actually it's 100 grand before we even start to think about installing anything on a server just to get one. So he thinks about it and he goes, well, I could justify the cost and go ahead. And if I do that, you know, to be honest, where that happens, usually there's a win. It's an early win, and the developer gets paid, the operator gets some gains, but it's more likely that he doesn't justify the cost because the guy that did the proof of concept didn't have the data from the operator to say how much money this thing was worth. So he had no way of saying, I can save you money, so you need to spend it. And it meant that most things went down this path. Most things go down the nothing happens path. This is in the past. In the worst case scenario, the operator does neither of them. And he just doesn't go ahead. He goes, it's just nah. And both guys just thinking, no, I don't know what to do. So another model that happens is where the operator has an idea. And he goes, you know what? I know exactly what I need. I need a box. And he says, I'm going to build it in Excel. That's just what happens. And he goes, there's my thing in Excel, and this is what we need. And he shows it to someone to develop an application and says, now I need that, but I need it running, and I need it to send me emails, and I need it to do stuff, right? So he does that. He pays the developer. He pays again to install it. And then the trouble is, but he kind of doesn't own it. He's not selling it to anyone else, and the developer kind of doesn't own it either. So he now has to bear all of the support costs for this technology, where it would have been shared in the other one, but that didn't happen, unfortunately. So the other problem with that is, so because he's got to bear the support costs, he has to do it all again, because actually technology changes. Oh, new version of Windows, need to rebuild stuff, lots of software problems people don't even have to worry about, and off they go and do it all again. And it's quite a shame that this happens. So that's got a little X at the bottom right for that reason. So we were thinking about how we could change this. How could we do this differently? How can we make things happen? Because something that gets me fired up is when we actually do stuff. You know, when we see blockers in the way that can take things away. But actually, when you get something real and you can see the benefits, that's what gets me going. So we create a new business model. What about if operators could connect to something for free? And this is actually unusual because usually when it comes to technology and you're connecting real data to it, people come looking for big sums of money. And what about if we weren't just the application developer? What about if we just open this up and let everyone develop applications? So every other vendor can come in here, pay nothing, connect to operators' data, which he connected for free, and go and analyze that and build an app that the operator can use. So now they can have a conversation, go and build something, and then the operator can try it. There's no install cost. It doesn't need to be on his network. It's in the cloud. It's new. So that 100 grand doesn't need to happen. And the upgrades, well, he doesn't need to worry about it. And in that case, we say, right, there's nothing to connect. There's nothing for the developers to be able to access it. But the point that we're getting value, all we're going to take is 10%, and the rest will go to the person that's developed the application. And that can be actually a pair of an operator and a developer, or it can be any sort of organizational unit. So that was the summary of that. And it's really talking about a different way of thinking about how we deliver technology. And it's a way that's really efficient for the developer. It means the operator actually gets value, because if he doesn't, you know what, he's going to stop paying per month. Rather than pay me probably a six-figure sum upfront and then walk away, which is what tended to happen in the past with some vendors. So what were we trying to address with all this? Data exists. It is there. There's plenty of it for the North Sea. And one of the things that frustrates me is actually the amount of data that isn't really looked at, isn't really analyzed, and is effectively put in the bin. So I believe that we can actually improve production in the North Sea. The applications that are developed in Monitor, they've classically struggled to be deployed, and they've struggled because of that initial hurdle, which we're trying to take away. Typically, data access has actually been limited by vendors. So it'll be a single vendor that will say, you know what, I've got your data. Now you've got to analyze your stuff in my tools. And that stifles innovation. It means the small guy can't say, well, I really know something about this individual single thing, and I know it better than anyone else, but I have to do it with all these different vendors. It doesn't make sense. They're unable to start. So these are the problems we're trying to get past with this. And monitoring applications usually have to store data, right? So we're talking about taking this and saying, actually, let's do this in the cloud. And when you go to an operator and say, you know what, I'm going to take your data, and I'm going to do stuff with it in the cloud, the first thing you do is to say, what country is that in? And you go, well, what do you mean? Well, do you realize there's legal agreements here? You can't store data out of country, right? That's not how it works. And every other platform requires the data to be stored with the analysis. But this is different. With this, the data is stored at site. So the operator keeps the data in his network, and we just create a route to the applications that can then store the results back to the operator's network. And that solves all the legal issues and makes it a hell of a lot easier for everyone. The other thing is that application developers struggle to access any data, and I kind of spoke about that a bit before, so I've jumped that bit on. But you imagine someone who wants to build a pump monitoring application. Then how do they start? You know, maybe they're just out of university. They've never seen this type of data. They don't know what exists. How do they start? So we said, well, actually, let's take some sanitized data that people are happy for us to share, and let's put that in the App Store, make it available to developers, so that actually that'll help them get over that first hurdle. So we're kind of helping our competition because it's in our best interest. And that's why I feel kind of unique here, because I can look at all of this audience and think you're all a customer, which is great. So this enables developers with really small outlays to create new technologies. And by really small outlays, I mean, I'm talking to Aberdeen University. I'm going to be going down to their entrepreneurship thing, where they take all the students and try to get them to create a new business and saying, do you know what, do you want to go build one of these? On you go. So that's the sort of low levels I'm talking about. It also creates a stream of revenue for the tool to allow the developer to maintain it. So unfortunately, most of the software models I see are unsustainable. It's a large license fee upfront, and then they kind of don't quite manage to keep up to date, because you might pay maintenance, but then that's kind of assumed. So why do they want to make it better? Why do they want to carry on? There's no reason, because you're already locked in. Where with this, each app you can walk away from, and you're only paying per month. So actually, it's in the application developer's interest to make sure that's the best damn thing at doing whatever it does, just to keep you paying. So cybersecurity is the one that everyone worries about, and one that we have to talk about. So all data is encrypted. It's all HTTPS, so no one can look at it. If they could, they'd be able to nick money from your bank account anyway. All the data is secured and is actually stored on the operator's network. We've done a lot of work to make this possible, and actually I do think it's really unique. I've not seen anything like it. No app has access to data unless you allow it. So although anyone can develop an app, that makes it available for you to use, but that doesn't mean that it can access your data. You actually say, I'm happy for this to use my data. I'm happy for this person to use my data. And it starts off, nothing can see anything. And it's all secured in their own networks. I've said that a few times. So why are we doing this? We believe that enabling the operators to switch from one vendor to another, it's a bit like, you know, your gas contract in your house, and being able to switch from the best one or the cheapest one means that actually you'll get the best deal. And if we help enable that, then we become part of that conversation. And we've seen far too many people redevelop the same old tools. So redoing the same thing again, but going through the same mistakes again. But if we create a sustainable model, we can move it forwards and actually allow people to see the value from it. So we believe that there's a new model needed when it comes to technology to allow the new capabilities at lower cost to come out. The burden in the past has been access to data, understanding the types of data that's available, supporting many different types of historians and types of data, actually. And that usually killed the small developers, so we're trying to help that happen. By doing this at scale, so this is all cloud-based, it's on Azure, there's effectively no limit. Everyone can win. The app developer gets paid because the operator has to pay to use the tool. We get paid because people use the App Store. We've put apps up there because we feel we need to get the audience in before anyone's interested. But actually, we don't mind if people do exactly what we do, and we want them to do it better than us. I dare you. Operators only spend money on what's worth their investment because they can choose. So that's me spoken about the opportunities in terms of the big money item that we're actually chasing. And I've spoken about a different way of making that an enabling factor, a way of creating a model that means that this might actually happen, because I've seen it not happen so many times. And now I'm going to go through some of the things that we've built that actually do that. And I'm going to actually take it down to money and explain how much money it's worth for an example asset that produces 20,000 barrels of oil a day, so a relatively typical North Sea asset. So, I spoke about two types of data. You get real-time data and alarm and events. We saw that from the Siemens presentation. You can take those data sources and actually use them. And in this case, we've taken alarm and event data. This is a compressor tripping, and this is 6 months worth of data on a visualization that no one else has ever even thought of. What it does is do cause and effects, but automatically straight from the data without having any model of the plant. So all you do is you stick your data in and you say, I want to prevent compressor trip, and it goes, here's the diagram. And you hover over these things. By the way, what's really interesting about this, red things are alarms. I think that's the anti-surge controller. These are interventions. Interventions are things that an operator does, and time goes left. So usually the first initiating factor in a compressor trip in this data set, which is real, is an operator action. And that's quite interesting. And I bet they're unaware, because there's so much time between this action and this happening, that they don't know they're doing it. So what's the value of that? And we went to town with this because we love dealing with numbers. So 6 out of the 21 were normal stops. One of those operator actions was actually switch off the compressor, right? So I'm not faking, it was real. And so 71% of them are preventable. But actually, if we say we could only prevent 28% of them, then that's roughly $2.2 million a year that someone would get in extra production. And that's not reduced cost. That's actually straight to your bottom line. It's $2.2 million that would be in the bank at the end that wouldn't if you didn't do it. And this can apply to any piece of rotating equipment. It can apply to anything, because it doesn't actually know what it's looking at. You just say, I want to prevent this, and it finds everything that happens before it. Another thing we do is a thing called Gestalt trend. It's really a bit of data analytics that's really built by engineers for engineers. And in this case, we're looking at, you take the wells on the left, you take the export line on the right, and as you see a kick here, you know it's going to move down the process. So great for brownfields where you don't actually have the great kit that's going to tell you this is going to happen, but it gives the operator a view to understand there's no point in trying to change this. This has happened already. There's no point in trying to change this. You don't have enough time. You might as well start focusing here, because then you can catch it where you've actually got control. And trying to give them the wood for the trees. So we estimate that at least 75% are uncaught excursions, and that's where you get an excursion. It could be slugging, it could be surging, it could be any piece of kit that's just suddenly switched on. It doesn't matter, but a sudden change in the process, we'd be able to prevent it if people could see this type of visualization, because you can't really visualize that much data on a standard plant diagram. And because of that, when you take the number of trips and the amount of time to recover from a trip, actually that's about $3 million for a normal asset per year. Oh, we've got a poster outside, and we're outside, so if there's any questions on this, don't be afraid to ask it then as well as after this. This is in a different space. So the last two were about preventing trips. This one's about optimizing. And So we took a look at that as well. And this is actually the Gestalt trend tool, but it's just a different view. And what we did was we took production. So this is a tag with data. We added a production. And we added the valve positions for each of the choke valves for the wells. Now, this shows correlation. And darker red means more correlated. So the more open a choke valve is, you would expect the more production you get. So in other words, you'd expect this bottom line to be completely red, but it's not. And that's really interesting. And it's really interesting because actually the realities of life are that we don't have a lot of instrumentation subsea. We don't know how much flow comes out of individual wells. And whilst we try to test them, actually the conditions we test them under aren't the same conditions we produce them in, because we'll tend to test them individually and they produce commingled. So when you do that, that's really interesting, because this well 3, when we open it up, that's minus 12%. Our production goes down minus 12% when we open this valve. And that's straight from the data. All I do is say, add production, add these valve positions, out comes a diagram, I hover over it, there's a learning. I don't know what the right answer is in terms of what they need to fix, but I know that they need to focus on well 3 and have a look at what's going on. It might actually justify doing some pipework changes, or it might justify shutting the well in. I couldn't tell you. But it was interesting hearing the 1 in 4, because it seems to be roughly the statistic on wells like this as well, in terms of the real data we've seen when we've put in here. It's about 1 in 4 wells is blue. So this is a tool that's available right now for anyone to use. And we estimate that you can probably increase by 1%, because that's about the lowest we could say. I mean, that was 14% in the previous one that we showed, but we wanted to be conservative and be realistic and not put up too big a number, because it gets a bit scary. So that's about $2.9 million a year. And dollars are almost pounds now. They're like almost the same. So in summary, I want to come back to the start and say, we really need to think about operating practices. And it's about enabling the right operating practices to happen. It's about saying, how do we have the right conversation? How do we have the tools help us speak to the operator and say, what's your current procedure for this? You know what, I can see how you do this. The other guy does that, and it seems to work out better. And we've got the tools to do that. So in summary, we reviewed the opportunities. The opportunity for us in the North Sea alone is $56.7 billion if we're looking up to 2035. And I like to think about that as a reasonable timescale to think about. We looked at the new software model, and it's costing less than $10,000 an app. No initial cost for anyone. And then systems for experts getting more than $1 million of saving per app per year for every single example. And that's just what we've thought of. There's already other people developing apps in the App Store. Wood Group are in there, and there's Astromar. So who knows what will come up next. And that's me.
Thanks, Steve. Do we have questions from the audience? Mark?
Cheers. Great presentation. I enjoyed it thoroughly. Just a quick question. Presumably, you would need a standardized data model for something like this.
No.
No.
No. I have been involved in projects in the past that have been all about creating a, I'm going to use inverted commas, standardized data model. And I have watched ones on the side that have spent multiple £1 million on standardized data model, which is different every time. And all of these tools are based on model-less data. It's the Google way, not the Yahoo way. There are some tools in the background of this which are driving this. So there's a thing we've got called tag intelligence, which actually tries to figure out what your plant is just from the data. So you don't have to tell it what things are. You don't have to create class models. You just go, here's my Pi server, here's my alarm data. And it goes, okay, what do you want to do with it? And that's where we're going. We've got tools doing that already. So controller consultant's one of them. You go in and it says, I found 63 controllers, here's your report.
Yeah, it's great to hear that. And I guess it's one of the biggest challenges for the industry. There are so many different data models out there.
There are.
that it just makes it a minefield.
It does, and you know, if we based it on any data model, then there would be some guy that didn't use it. So we took the lowest common denominator and said, let's assume no model. We're Pi partners, but if you've got stuff in EF, we ignore it, and we just go and look at the data.
Great, thank you very much.
Thanks.
So no more questions?